Let's talk about the hexadecimal number system. And if you take the name hexadecimal, hex meaning 6, deci meaning 10 or base 10, we have 6 and 10 making a base 16. So a hexadecimal number system is a base 16 number system. You might ask, why do we have a clock on the screen? Well, a clock is the easiest way that I know of to explain a base number system other than 10. You know, a clock being base 12. So you've been doing this type of arithmetic all your life using the clock. So there are some other terms you need to know. Base 12 is the same as saying it's modulus or modulo math. It's the same thing as saying mod 12. It's the same thing as saying modulus 12. It's or modulo numbers. It's modulus math. All the same thing, you know. So we have the clock. You know, we've been doing this for a while with military time. Let's take the number 23, right? Because most of us know that 23 is 11 p.m. right? And how do we arrive here? We are dividing by the base number 12, or the mod. We're saying it's mod 12, which just means we're dividing by 12 and looking only for the remainder. Yes, we are only interested in the remainder. 23 divided by 12 equals 11. That's how 2300 hours equals 11, right? O'clock or 11 p.m. because 11 is the remainder when we divide, 23 by 12. So that's all we're doing. We're going to switch over to 16. We're going to divide by 16 instead of 12 in order to do the conversion. Yes, it is that simple. You're simply dividing by 16, but only paying attention to the remainder. Here's another clock. In this example, you can see I'm highlighting 13. 13 equals 1 o'clock, or we know that as 1 p.m. right? 13 divided by 12 with a remainder of 1, and the 1 is all that we really care about in this situation. We call this modular arithmetic, or mod, or modulo. It has several names, or base 12. We're going to switch over to a base 16. Now, base 16, our founders of computer science decided to make some adjustments. So we have 0 through 15 instead of 16, on a clock. On a clock, we start at 1. But we need 0, right? So we're not leaving 0 out. 0 through 15 is the middle column. Please understand that is the first 16 numbers. So we are indeed on a base 16 system, right? Base 16, 0 through 15. I hope that makes sense because we're not starting at 1. So we're not going through to 16. We're stopping at 15. The first 16 numbers stop at 15. Our computer science founders, they understood they weren't dealing with a clock, right? A clock, the numbers repeat. 1 o'clock, 2 o'clock, 3 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, right? They keep repeating. When we do our conversions to base 16, we are not going to be repeating a number, right? Because natural numbers do not repeat, unless we repeat them. But natural numbers just keep going. We need a system to display base 16 without repeating our base 16 number. See, on base 12, like a clock, we repeat 3 o'clock. And in fact, we repeat 3 o'clock twice a day, let alone the next day and the next day and the next day, right? With natural numbers, we will not be repeating. So they thought of this, they thought of many things, but they ended up with this. When they get to 10, they're going to go A, B, C, D, E, F, right? Before starting over. And when they start over, they're not going to start over at 0. Okay? So they had to think about a system, right? So here we go. Check this out. You can find tables like this online. The first 2 columns here up in the upper left-hand corner represent the decimal and the hexadecimal, right? Equivalent. You can see 10 equals what? A. 15 equals F. Look what happens when we get to 16. We don't start over at 0 like a clock, but that's when we reach 10, right? Multiples of 16 is when we almost start over, but we're not starting over, of course. Okay. Let's go. What is the next multiple of 16? Okay, I'll give you 2 seconds. You should have said 32, right? 32 is 20. Notice 31. Notice 31 is 1F. 32 is 20. What is the next multiple of 16 after 32? Give you a few seconds. You should have said 48, and you should know your multiples of 16, at least the first 3 or 4, especially in computing. 48 is 30, right? Our next multiple of 16 happens to be, you guessed it, 64. 64 is when we start 40 in hex. And you will see the pattern, right? You will see the pattern. The pattern is easy. You can even, do the conversions by just using the pattern. But once you start to get to large numbers, the pattern gets harder and harder to follow, right? So we need things such as this, a calculator. We put in 15 and we get F. How do we get F? Because the hexadecimal, the hexadecimal equivalent of 15 is F. It's right before it starts over. Well, not quite start over, but it's before it gets to, it gets to 10. So 16 is 10, 15 is F. Now we can also do some calculations ourselves. Let's do some simple calculations. Let's keep this simple. That was the whole purpose of the video. There's a ton of stuff out there that's complicated, right? Let's keep it simple. Let's do 35. Okay. 35. We only want the remainder 35 divided by 16. When we only want the remainder, I'm writing with a mouse, so please forgive me. When we only want the remainder, we're not going to use the division sign. That's inaccurate. We're dividing, but we're only interested in the remainder. When we're only interested in the remainder, we use a percent sign. Yes, a percent sign is an operator. Yes, it is. So 35 divided by 16, but we're not interested. We're only interested in the remainder, right? We know we go 16, 32, 48, 64. 16, 32, 48, 64. So 16 goes into 35 2 times, which is 32, which ends in a remainder of 3. When we keep in mind that, we on that chart we saw before, we saw that I'm going too close to the edge. Let me move back over. We saw that 16 equals 10, right? We saw that 32 equals 20. Remember that? And so I'm going to think that 3 more, right? 3 more than 32 is going to be, we're just going to go, it's going to be 23. Yeah. So it's our final answer is going to be 23. All right. And we can test that out. We can go to the chart and we can see that 35 is 23. All right. Now let's do one that's ends in a letter. Okay. Because we need to practice getting some answers with a letter. Let's leave the 16 in the equal sign, and let's leave that percent sign, and let's get rid of 35. Now we know, if you remember, I don't know if you remember, I remember that after 10 it starts with the letters. 11 through 15 are A through F. All right, so let's go with, let's find 31. 31, converting that to hexadecimal or mod 16 should give us an alphanumeric value, right? A letter and a number. So 31 divided by 16, but we're only interested in the remainder. Okay. So we know that 32 divided by 16, we know that is 2. So we're going to have one remainder 15 here. You can do this math right now. I'm doing it mentally, but you can do 31 divided by 16 is going to be 1 remainder 15. We're only interested in the remainder. Just like when we're telling military time, we're only interested in the remainder. 15. So 31 converted to hexadecimal is 15, but remember, some numbers were replaced with alphanumeric values. So let's go to our chart, and we're going to find 15 isn't stated as 15. 15 is one of those that was replaced. 15, it was replaced with F. So our hexadecimal value equals F. That's pretty savvy, if you ask me. I'm sorry, I'm impressed. I'm impressed that they came up with this. You know, this is a snazzy, nice table where you can see the patterns, right? You can see the patterns, but it all works on a base system or of modulus numbers, where you're completely taking the remainder and you're dealing with the remainder, just like a clock, just like military time, right? But instead of base 12, we have base 16, right? And because we could not repeat numbers, they had to devise a system here where each conversion would be a unique alphanumeric value, you know, rather than a numeric value. They switched over to alphanumeric means combining numbers and letters to make values, right? So they switched over to an alphanumeric system, and this is your hexadecimal or base 16 or modulus 16 or mod 16. right? Modulo numbers. I hope this helps.